Good morning and welcome to the second day of PyCon Sweden 2020. Sorry for the delay, online presentations sometimes are a bit tricky, but we managed. So it's a great pleasure for me to introduce to you Alexander Hultner, who visited us at PyCon the previous years as well. So he is a freelancing consultant and also a driver of the Nordic Python community. So make sure to check it out on Facebook. So alongside consulting, he is also performing workshops and courses, and he is currently making an online course on property-based testing in Python. You find the form to sign up in our program in the description, and of course on his webpage. So I hope you are as excited as me to learn about the evolution of modern Python. So please, everybody, welcome Alexander on stage.
Hello. So I'm Alexander Hultner, and I have a keynote today titled Evolution of Modern Python. So let's get into it then. Let me just get my slides up here. So as you just heard, my name is Alexander Hultner. I have my own company, Hultnér Technologies. Here's a picture for me at PyCon Sweden last year, actually. And you can find me on Twitter or email me. Also, the slides for this presentation and most of my other presentations are available at slides.com/Hultner. So it's very easy for you to get them there. And if you want to follow along directly in the slides, or if you just want to get any of the links in the slides afterwards, they're available there. Oh, my focus is dropping. Let me just fix that. So all the links is available there. And I will have links for all the stuff I reference throughout the talk. So short introduction to my talk. So this is the year that we left Python 2 behind. So this means that we can finally look forward. And therefore, I want to focus on all the great things that's been happening on Python 3 or in modern Python, as a lot of us likes to talk about it. So in this talk, I'm not going to talk a lot about legacy Python, which is Python 2 then. Instead, I'm going to focus on Python 3 and especially what's been happening after the initial release. So I'm not going to talk about the differences between 2 and 3. Instead, I'm going to talk about what's been happening maybe the last 5 years or so in Python 3. So just some ground facts is Python 3 was first released in December 2008, so that's 12 years ago. And Python 2.7 was released in 2009 and officially end of life at January the 1st this year. So this is pretty much everything I will talk about when it comes to Python 2 today. Other than that, I will mainly focus on Python 3. So in this talk, I'm gonna take you on a journey where I talk about how I got introduced to Python 3 when I made my transition from legacy Python, and then I'm gonna walk you through the things I discovered while going from Python 3.4 to 3.5 to 3.6, 3.7, 3.8, 3.9, and I'm going to talk a bit about the future. So let's get started then. So where it all started. So back in 2015, I was working at a company called Heliospectra. Heliospectra is a smart greenhouse technology company who builds LED grow lights for industrial greenhouses, but also smart control systems for commercial greenhouses, and even works with the ESA, European Space Agency, on a project called Eden ESS. Maybe any of you have seen The Martian, which is something we talked a lot about when we were there, because it's quite similar to that project. Anyway, so back in 2015, we had been mainly a research-focused company, and we're going towards a more industrial approach. And our old control software was a native desktop application, which was more aimed at smaller installations and more used by researchers or early adopters. But now we needed to get a better approach for industrial scale. So something server-based where we could integrate all parts of the greenhouse in one system. So this is, I just wanted to show a picture. This is from the Eden ISS project. So all the lights you see here are from Heliospectra's lights, and they are even running on a custom water-cooled loop in here. And this is running in a container on the South Pole to most closely possible simulate the conditions in space, so so that they can be prepared to one day take out in space and actually produce food in space, basically. So anyway, I'm not going to talk a lot about that. I just wanted to show this picture, but let's go ahead. So it started that we wanted to generate or build the next generation of control systems. So we were just about to replace our old control system, which was this native desktop application that was more aimed at smaller installations. And our new approach would be server-based, as I said. Basically, we needed to adapt it for commercial greenhouses and industrial scale. So we needed in-facility hardware, basically very resilient servers that can handle the humidity and heat and everything else you get in a greenhouse. And we also needed to be able to remote control the system, but the system still had to be fully functional even without an internet connection, because you don't always have the most stable connection in a greenhouse. They can be in a very rural location. And we also needed to support third-party integration, so other hardware vendors delivering sensors or other systems where the greenhouse could integrate with the same control system and have one integrated smart system. So I had for a few days built a modest proof of concept, and I was using the core of our existing Python 2.7 application. I had just ripped out all the desktop UI parts, which was built on Qt in these days. So I then threw a JSON API wrapper around it and built a very small JavaScript SPA. And this was the first time I was actually running it as a web application that could be controlled remotely. So I threw all this onto a first generation Raspberry Pi. So not very beefy hardware, but did the job for the proof of concept. Anyway, this was the first time I could actually fully control all this amazing hardware with the flick of my finger on my iPhone. So that feeling was truly marvelous. And I felt that this is really the way we need to go. So at this point, I think everyone was convinced that we were going to build this new system. But when we decided to go forward, we had said that we will use Python. There had been tries before to switch to another language, but they hadn't been completed or successful. And I wanted to be able to reuse as much logic as possible from our old version. But we were running Python 2.7, and we did have some scalability problems that we were running into with our current application, especially when you have several hundreds or even thousands of hardware IoT units communicating over the network with a single computer. Your processing and threads start to cap you out at this point. So we had to make a decision how to go ahead. Where we're going to use Python 2.7. There were some libraries that only worked on 2.7 in the old system. And the sunset date had just moved forward from 2015 to 2020. So it was possible, but I'd prefer not to do it. So So we had to think a little bit about this. And we decided that we can use Python 3 and still use 2.7 if we really have to, if we build it on a modular architecture. So basically, I designed a system where we used inter-process communication over Unix TCP sockets, or actually local sockets. And this enables us to use multiple Python versions and even multiple languages if we want, and makes it easier for us to integrate the entire system with third parties. So this became a kind of foundational thing of the entire system. So each component had its own process, which then communicated over these Unix sockets and APIs. So that meant that we could feel completely comfortable using Python 3.4 and eventually 3.5 once that was out. So turns out that Python 2 was never needed. The small parts that did not work in Python 3 was either possible to completely remove, or we could quite easily port them to Python 3. So it wasn't a big problem as we first thought. So doing it this way gave us the confidence to actually go forward and use modern Python instead of staying on the legacy Python, because we had the safety net. We could always build one process or one module that worked on the legacy Python version, but we never had to, which was really nice feeling. So yeah, as I said, the few libraries we worried about were either superseded by new libraries that worked on Python 3 or weren't a problem. So a few months later, we even upgraded to the then brand new Python 3.5 and instantly started to utilize new features like the splat operators, which probably a lot of you use every day these days, but it was a cool feature back then, and I remember being impressed by how much easier it made some things. So at this point, I was fully convinced that Python 3 was not only the correct move for us, but it was a truly great new Python version. And even though the transition was slow, I did really enjoy being on Python 3. And 3.4 was the version when I really started moving away. So yeah, I was convinced. And that takes us to some of the features about Python 3.4. So Python 3.4 was released in March of 2014, 17th of March in 2014 to be exact. So Python 3.4 introduced some features which we probably see clear as a bell today, and some great benefits of modern Python, but that actually didn't exist in the initial release of Python 3. So one of those is the Enum module. I use this every day, but basically this gave us a standardized way to have enums, and that was done in the PEP 4.3.5. And yeah, I think it's one of those things that's really obvious when you think about Python 3 today, and one of the advantages with using modern Python, but it wasn't actually in the initial transition. Another such module is Async Io. So this was before await keywords, but async and await. But basically the fundamentals that we use today for all our async things were added in Python 3.4. So with Async Io module, we could finally have some nice standardization of Async Io in Python. And another one of those that I think are really amazing and I use a lot is pathlib. If you haven't used pathlib and you still use plain string paths, I think you should really look into it, because it does make working with files and paths much more smooth. And after this initial release, a lot of effort have been put into making the entire standard library compatible with pathlib. And if you ever have to fall back to using plain string paths, you can always cast a pathlib path to a plain string. So you're never locked into pathlib. Yeah, having a nice interface for paths that's actually a bit smarter than just using plain strings is one of those features I appreciate with modern Python, and it's a part of the evolution after the initial release. So there are, of course, many more new features, and if I were to talk about every new feature, I would probably stand here all night. So instead, I've added some links at these slides. So if you go to slides.com/Hultner later, you can read the release notes there. And of course, all the blue links here are also clickable, so you can go in and read more about these things if you want. So then let's continue. So after Python 3.4, I talked a bit about Python 3.5, which we had also started to utilize. So Python 3.5 introduced some of the features we've learned to love and embrace in modern code bases today. Some of the really fundamental features of Python 3. One of those is type annotations and async await. Maybe some of the most desired modern Python features in new projects today. So I'm going to talk a little bit about some significant features added. I talked very briefly before about the splat operators. This was probably the first killer feature of Python 3.5, because back when it was released, I didn't start to use async await at once. I mean, I do use it today, but it wasn't something I used the first maybe 6 months or a year or so. I didn't use the type annotations either. But of course, it was super nice that we got the coroutines with async await syntax. And by adding them already back then, we have actually had some time to get a healthy ecosystem of libraries and tooling that actually utilizes these today. And as I said, of course, the PEP 484, a standardized typing module and a new standard for type annotations. So some of you remember the old comment-based type annotations, and I think we all agree that the new modern Python style type annotations are much better to work with. Another thing is improved zip application support. Some of you maybe don't know about this, and some of you do, but basically from Python 3.5 and forward, Python could actually execute zips directly. If they had a Python shebang, you could even execute them without sending them to Python. So basically, by zipping your application, having a dunder main file in the zip, in the root of the zip, you could then just add your Python shebang to the start of the file, and you had a self-executable Python archive. Of course, it's still dependent on the system installed version of Python, but we've seen a lot of tooling built on top of this or building on these ideas today. One of those is Shiv, and there are others as well. But I think it's one of those really nice things which still isn't utilized as much as I'd like to, but it's really nice to be able to actually pack all your dependencies into a single file and execute it. And of course, many more features in the release notes. So I really like Python 3.5. It added a lot of the features that we that we really enjoy today. So this was 5 years ago, more than 5 years ago, and it feels like time's just been flying. So let's continue with my journey then. So time to level up. In 2017 to 18, I had taken a new turn on my projects. So I was prototyping a new application, which gave me a great opportunity to utilize a lot of the newer features that had been added more recently. So next up was Python 3.6, and I immediately fell in love with the new F strings. So modern Python was not only getting better for every day, but it was also getting more friendly to use. And this was one of the great steps. It's not a big thing with F strings, but it really made code more readable and something that I see as an obvious thing in a modern Python code base today. So I was prototyping this new application where I started to utilize many of the features added, both in Python 3.6 and forward, and in the previous version, I mean. So using type annotations helped me catch mistakes early on, so much so that I wanted to use them even more. So I looked around and looked for ways to utilize them in even smarter ways, and found an early version of data classes. I've seen that Eric Schmidt was working on this rather exciting concept for Python 3.7. So, and that concept, of course, is data classes. So they allowed us to combine type annotations with a more helpful class syntax and with a lot less boilerplate. Python was yet again doing something I really admire. It was getting more better features, but still getting more approachable at the same time. So armed with an early reference implementation for Python 3.6, we started using them in our application stack about half a year before it was actually released with Python 3.7. So you could actually install it via pip back then. And you still can if you run Python 3.6 and want to use them. So that's something to keep in mind for you who are stuck on Python 3.6 as well or haven't upgraded yet. So I was really excited about these data classes. So I took a weekend project and hacked a little bit more around on them and found them quite exciting. So I built a very simple runtime type checker and some JSON parsing format and formatting utilities. So this was mainly just a cool weekend project, but it showed how easy it was with very little effort to access the types via the dunder annotations property. And this made it even more straightforward than I had ever imagined to implement the runtime type checking. So I wanted to share all this newly gained knowledge with the world, of course. And I've always enjoyed to talk about the things I've learned and the things I find interesting. So that subsequently led me to present a couple of talks about data classes. First out was GovPy. So this was in 2017, I think, yeah. No, 2018, early 2018, yeah. So this was in the spring of 2018, and just a couple of months before the Python 3.7 release. And later that winter, of course, as some of you maybe seen or know, I had that same talk or an updated version of that talk at PyCon Sweden. And this was, of course, after the 3.7 release. So for the PyCon Sweden version, I could actually update the talk with all the stuff that turned out to change or happened in the final release. But actually, it wasn't a lot different from the early versions. So I added some pictures here from my PyCon Sweden talk back then. Yeah, I mean, I really like having this remote thing, but it's very nice as well with the social aspect of being able to see you all. It does feel a little bit strange to talk into a camera and not being able to hear the audience. Anyway, so yeah, I had this talk at GovPy and PyCon SE, as I said. And as for the runtime type checker and the JSON utilities for data classes, I never quite came around to finish them up enough to release them or get them into a state where I was proud enough to release them publicly. And largely because I, a little bit later, found another project named Pydantic, which was taking a road where it ended up in a very similar place and with similar goals as I had with my own library, and of course surpassed it by far. I actually did have a talk earlier this year about this at PyCon Pizza, and I also created a YouTube video based on this talk, so it's on my YouTube channel if you're interested, and it's also linked on the Pydantic help page. So if you want to learn more about Pydantic and runtime type checking, then I recommend either just seeing my talk or just playing around with the library. I just need to breathe a little bit. My voice is, yeah. So Python 3.6 then. It was released in December 23rd, 2016, so the day before Christmas, an early Christmas present for us here in Sweden. And most famously, Python 3.6 gave us f-strings, as we've talked about. But it also gave us a lot of the fundamentals that enabled us to have data classes. And as a side effect of performance optimizations in dictionaries, they did become ordered in the CPython reference implementation, a de facto standard at the release of Python 3.6, which was later formalized in Python 3.7. So, of course, f-strings, yeah, the most significant feature in 3.6, according to me. Something else is preserving keyword argument order. I haven't looked into this, but I wouldn't be surprised if it was related to dictionaries actually being ordered in 3.6. We also got Async Comprehensions, which is also a very nice feature. And as I said, order dicts a de facto standard, but it was there. A data classes backport via pip install. So some of the nice things with Python 3.7 was already available in 3.6. And I had to include this as a fun thing. I didn't know about this until the other day when Raymond Hettinger wrote about it on Twitter. But they actually added math.tau on in the standard math library in Python 3.6, which is 2Py for those of you who aren't familiar. But I thought it was a fun thing. And of course, there's a lot more features in the release notes, so you can click there if you want to read more later. And I just included a very short example here showcasing how nice it is to work with f-strings. So basically, I created a hello PyCon function where I just interpolate the speaker name, the talk title, and the talk time. And of course, this is obvious today. I mean, looking at this and reading the code, for me, it seems like the most obvious way to implement something like this. But we have to think that this was not in Python 3 for the first, 8 years? Yeah, from 2008 to 2016. So let's go ahead then. We've talked briefly about Python 3.7, and now I'm going to go into deeper detail. So as I said, Python 3.7 was released in the summer of 2018, so actually June 27th. So somewhere in the middle between my GovPy talk and my PyCon Sweden talk. And some of the significant features of Python 3.7, of course, was the ones we started to get in Python 3.6, but that was actually formalized at this point, while also bringing some significant performance improvements. So one of those was, of course, the order dicts as an official standard this time. And of course, built-in data classes, which I really like. And another thing that isn't talked about a lot, but is something I've utilized a lot, is the two-way ISO format for datetimes. So in Python 3.7 and forward, you can both format a datetime to an ISO string, but you can also parse an ISO string without using any third-party libraries. And this required you to either write your own code to handle it, which can be fragile, or install some third-party library before to handle ISO formatted datetimes. So this is really useful when building web APIs, for instance, which usually sends these a lot. And of course, we had some quite significant speed-ups and many more features in the release notes. So 2019 to present then, a new dawn. So 2019 came to a great start for me. I reincorporated my business, Hultnér Technologies AB. I also talked about property-based testing a lot this year. So I started with the hypothesis talk at FOSS North early in the year. I later went on to have the same talk or adaptations of the same talk at GovPy and PyCon SE. And property-based testing is one of those things I really, really enjoy with Python 3.7. So around, let's see, focuses. Okay, let's just see if it catches back. Okay, I'll just continue. So around this time, I was playing around with the alpha version of Python 3.8. And one of the both famous and infamous features of Python 3.8 was the Walrus Operator. And I did write an article about this. And the picture you see to the right here is actually from that article, the featured picture I picked for that. So basically, with the first alpha version just out, I took the opportunity to write this article, which was titled "Try Out the Walrus Operator in Python 3.8," where I took an objective and informative look on the feature from a technical standpoint, without going into the opinions and the lively debate which had surrounded the feature in its early days. So I had never expected this article to gain so much traction or popularity or at such a pace, but it was featured by the Medium curators in the programming category. It was trending on prominent tech communities and sites, featured on multiple Python sites. It ended up in a lot of newsletters, even on the Python Bytes podcasts, for those of you who are familiar. And the article still switches between first and second highest ranked result if you search in Google for Walrus Operator. So I was quite happy about that. And the article has since long passed way over 100,000 views. And I haven't had as much time to do technical writing during this early time in my company, but I'm planning to pick it up more again next year. A lot of other projects have taken up all my time this year. So yeah, as I said, it was more popular than I ever imagined. Yeah, I forgot to show this out. Yeah, And yeah, I told you that I had the property-based testing talk. So let me just see if this helps. Okay, we're back. Yeah. Autofocus. So a new dawn, part 2, 2020. COVID hits, but we still have gotten quite a few good things in 2020, and today I want to focus on the positive things. So the Python 2 end of life, and hence this talk. So I probably wouldn't stand here and talk in particular about the evolution of modern Python if it wasn't for the end of life date of Python 2. Another thing is remote conferences, which has increased accessibility of these conferences a lot. And I've been able to talk at new conferences every month, but I do still miss the social aspects. So I hope once this time is over that we can have both remote conferences like these, but of course in-person conferences again. Python 3.9 is out, which is quite nice. And lots of interesting things is happening in the Python world. Some of those is Schema Physics, a project I've been quite involved in and had a talk at EuroPython, PiterPy, and FlaskCon about this year. Another thing more recently was Piston 2, which does look quite promising. And of course, less time commuting have led to a lot of us having much more time to experiment, which also is very nice. And talking about experimenting, I'm going to tell you a little bit about the project I've been working on for last half year almost. So I've been experimenting with my dear friend and colleague Magnus Junghard, and on a new project named Papero.io. And this project has been a testing round where we've been able to once again utilize all the latest and greatest Python features, including Async Io, both in the backend and the front end. So we run fully on Python 3.8 for a few things that still doesn't work to upgrade to 3.9, and 3.9 everywhere where we can. And we have Async Io both in the backend by using the excellent FastAPI Starlet-based framework, and Starlet is an amazing ASCII toolkit for creating async libraries or applications. But it also helps us in our heavy lifting in our task workers running in the background. We use type annotations everywhere, and everything is type checked with MyPy, which does give us some extra comfort and security in our systems. And we also use Pydantic, which keeps the runtime type validation and IO data for IO data in check. Not only for the user-provided data through the API, but also from other external sources like the database or third-party APIs. And we then generate our TypeScript types for the front end automatically based on these backend types and schemas. So this makes the entire process very efficient, but does also give us a lot of extra reliability and makes us able to trust our system more. So yeah, as I said, the Pydantic runtime type checking. We used randomized testing and property-based testing on the backend, which gives us more resilience and makes the entire code base further tested beyond just line coverage. And it does enable us to deliver better results faster. So both the property-based testing, which goes way beyond static PyTest tests, but also all the other new improvements in Python and modern Python. So I think it's truly astonishing that nothing of all this has really slowed us down at all. And it's unquestionably enabled us to deliver better results at an even higher pace than ever before. And this is what I really love about modern Python, about Python in general. It's always continually evolving, and it does it in a way that further empowers us as developers and lets us deliver even better results even faster. I mean, for every version, it feels like the code becomes just more obvious and clear. And I think the ergonomics of the Python language is brilliant. So I've talked a lot about this Papero.io now. Maybe you wonder what it is. And yeah, I'll tell you what it is, but I'm not going to go too deep into it here. But the gist of Papero.io is that Magnus and I were tired over how much we struggled with creating attractive, well-looking, and beautiful PDF files in a dynamic manner and in a scripted way that felt natural. Working with tools like Illustrator and InDesign always felt like a little bit of a struggle. So we decided to fix this and created a way to build these more in a way we felt more natural. So we were both born in the rise of the internet and we are both proficient with web tooling. I started my own career in the web and agency world back in the late 00s. And I worked both on the graphical and the technical sides of things before going to university. So for me, I mean, it's not very hard to create a good-looking PDF, for instance, in Illustrator. But creating hundreds of them and using diverse data and content is much more troublesome. So what we did then was what obviously made most sense to us. We solved our own problem by creating a service that allows us to create stunning PDFs using standard web tooling. And we can all of a sudden leverage HTML and CSS, even client-side generated JavaScript applications powered by React, Django, Flask, FastAPI, Jinja, or whatever your flavor is. You can use it to create PDFs using Papero. So maybe you want to generate reports visualizing complex data in a very nice way for sending out over email or printing. Maybe you just want good tickets, maybe invites, tailored receipts, invoices, packaging slips, return labels, flyers, pamphlets, manuals. These are just a few use cases that we've had ourselves for this and the kind of things we see that it enables. And we're actually launching the closed beta for our new service today. So we just opened the beta invite waitlist at papero.io/beta. So go in there and sign up if you're interested, or just hit me up and I'll schedule a demo for you and we'll do a one-on-one. So, okay, now I'm gonna go ahead with the evolution of Python. So Python 3.8 then, which we do use in Papero then. The release date was in October 14th of 2019. And this was the first release under the steering console. And follows from that is that there wasn't a lot of big changes, but it was a big step for the future of Python. Of course, we all were sad to see Guido leave, but in the long term, it's probably wise to have a democratic process instead. So I think it makes a lot of sense. And of course, as I talked more about before, is the PEP 572 assignment expressions, or as they are popularly called, the Walrus Operator. This was probably the most significant feature, but we also got positional only arguments, which does matter for some C bindings and external integrations. and some general stabilization of the entire Python code base. And of course, more things in the release notes that I didn't include here. So after that, we got Python 3.9, which just been out for a month now, came out in October the 5th in 2020. And here we did get quite a few significant features. So I'm just gonna try to keep it to a few. But one of the really great things is that we now have stable annual releases. So we have a predictable way of knowing when new Python versions will be out. And we will have stable releases every year, which is very nice. We have union operators in dictionaries, so we can merge dictionaries using a pipe B or a union B instead of using the splat operators, which some of you probably have done, where you create a new dictionary by expanding A and B. And of course, it does have some limitations for certain types of keys. So that's actually a very nice improvement. We have type hinting generics in the standard collection. So we can now use list directly with a small l, or dict, or set, or a lot of the other built-in types instead of importing list with a big L from the standard library to get the generics. So this makes it just more convenient to work with the type system. And I think it's nice. And we have the new PEG parser for CPython. Of course, we won't see a lot of big things right now based on this, but it will enable Python to take new leaps in the future, to do some changes in the syntax. And I'm going to talk a little bit about this later. But more, of course, in the release notes. So we're getting near the end of my talk. And basically, what does the future hold for Python? In the near future, we have Python 3.10. We will likely get structural pattern matching, which gives us pattern matching based on our type annotations. And it's one of those nice things that is made easier with the new parser, and maybe even possible. MyPy is constantly evolving. We're getting new type checkers as well, popping up every day. So we have PyFire, PyWrite. Yeah, there is a bunch of them now. Community is growing at an ever-increasing pace. We're seeing new editors. We have gotten PyCharm in some years back, and VS Code has been making great strides with their Python extension, and the new PyLance extension is really amazing. And for old diehards like me, there's still great ways to use Vim, and we can even integrate it with some of the new things. And of course, further ahead, there might be a Python 4. Will it be another 2 to 3 transition? No, it won't be. Everyone's learned from the mistakes from the last time. And the developers hadn't imagined how big the transition actually would become, or how big the Python user base is. So with all these new learnings, and with the today much larger and very active Python community, we won't see this kind of breakage again. So whenever Python 4 will come out, we'll see a release that's easy to update to and won't have very large breaking changes. So that was everything from my talk today. And if you want to contact me, here's my contact details. You can reach me on Twitter, email. I'm on GitHub. I have a GitHub repository for this talk. I make a repository for almost every talk I have. Go to prepare.io if you want to sign up for the beta there. You can see my previous talks on the link here to my YouTube channel, where I have a playlist with most of my talks, that at least those that are available on YouTube. My website is hultner.se. Slides are at slides.com/Hultner. And of course, I'm Hultner on LinkedIn if you want to add me there. As you heard before, I'm also available for training, workshops, and freelance consulting. So contact me if you have any further questions. So that's everything for my talk today. Do we have any questions?
Yeah, first of all, thank you very much for your presentation, Alexander. There was a really nice walkthrough through the different versions of Python, and I think it's so interesting to see what features we just take for granted now when we work with newer versions, and you don't think about, oh yeah, f-string, that was a big change. So I really changed the, I really share the appreciation for f-strings as you do, I think. So we have a question from Helio. What do you think would be a great feature for Python 4.0?
I mean, it's very hard to know what will happen, but to take something a bit more close in time, I really look forward to the structural pattern matching. I've used Haskell in the past, and of course Haskell isn't as approachable as Python, but the type guards in Haskell makes it very convenient to work with type data, and makes it much easier to do some dispatching based on that. So I've used Dictionaries for similar dispatching with function references in Python, but it doesn't look at all as nice as using the structural pattern matching. And I think the PEP looks really amazing. So I'm really looking forward for that feature.
Thank you. Do you have any more questions? So maybe more a soft skill question. What do you think you learned from presenting at PyCon Sweden and GothPy?
Well, I mean, I do get some more experience talking with people, especially presenting technical subjects. I always loved having presentations. I mean, even when I was in middle school and when I was in high school. So it's always been natural for me to have presentations. I really like being able to do that in my profession now as well. And I super much enjoy being able to give back to the Python community. I really like everything that we get from Python and how it enables us to be more productive at our work. So I want to give back as much as I can to the community whenever I can.
Thank you. Yeah, I really like your talks. So we have another question from Lilian. Could one say that currently the most developments are taking place in the Python language as opposed to other languages?
I'm not sure exactly how that is meant with opposed to other languages. I mean, other languages are making strides as well. What I really like about Python, I'm not really sure about the question, so I'm going to answer what I believe anyway. But what I really like about Python is that all these new features makes the language more convenient and easier to use. I do use JavaScript and TypeScript quite a bit for front-end stuff, and I've been a full-stack developer for all my life, basically. So I do not see the same things in the JavaScript world. I mean, I probably code as much JavaScript as Python, but I don't enjoy the language in the same way. I don't feel the same joy. It doesn't feel as natural. And every time I've been away from JavaScript for a year or two, which does happen every now and then because I have a lot of other things, I come back to it and I look at it and there's new syntax and I don't understand the new syntax without reading through the specifications, and a lot of libraries are breaking and a lot of things have changed since the last time. I have the feeling that it's much more stabilized in Python and that the features, it's being put a lot of thought into every feature so that it's very obvious. They don't add a new feature just because it's cool or because it's the latest, greatest thing. Instead, the Python developers make sure to really investigate how does we make this ergonomic, how does we make it nice, how does this actually improve the language, does it add anything of real value, and first then they add the features. So in one way, by being restrictive in how they add features, I think the language is much greater.
Thank you. Then we have one more question from Magnus. Oh, is that your Magnus?
Yeah.
Is there any feature you're missing that you think would fit for the near updates to come in Python 3?
I mean, I really like the type annotation stuff, so I would love to see more around that. One of those things is the type guards. Another thing would be having something like MyPy being first class in the Python implementation, being able to maybe utilize the types even more. For instance, some of you have heard of MyPy C, which is still in very early development, but a new way to build Python extensions using type annotated Python code instead of the older Cython API, which isn't quite as nice to work with. So that's something when that stabilizes and when that feels really mature, I'm looking forward a lot to be able to utilize that to really improve my Python code bases.
Thank you. Okay, I think that was the questions for today. So thank you again, Alexander, for this fantastic presentation. And everybody make sure to check out his webpage, Hultnér.se. And I hope to see you at the next PyCon Sweden as well. For today, we will branch out. We will branch out into the different tracks again. So you find, as yesterday, the links to the different YouTube streams in the program. And we hopefully see each other here in the main track for the afternoon keynote with Lucy at 3 p.m. So thank you, Alexander. Enjoy PyCon, and
thank you.
See you soon.
Yeah, thank you for having me.